welcome to the first video in the 3 Caillou series. This will be brand new. It's called Railfence Cipher, Encoding and Decoding. So you're implementing these two functions. They provide encode and decode, and they are giving you a string and a number of rails, and this is how it works. You can consider this glob here, we are discovered, flee at once. And so the idea is that imagine these rails as horizontal rows like this. This would be rail 1, this would be rail 2, this would be rail 3. So in our example, n would equal 3. N is short for num rails, and why don't we just be explicit about that? Okay, so look at the input. The first character is capital W, it goes in rail 1. Second character is an E, it goes in rail 2. Third character is an A, it goes in rail 3. Now when you get to the fourth one, you notice how you don't start from rail 1, you go back across rail 2. That's where the R comes from, the fourth character. Then you got an E that ends up in rail 1, then to 2, 3, rail 2, rail 1, rail 2, rail 3. That's sort of the weird pattern that it makes. So with the effect, I like to think of it like you're dealing out characters like playing cards, but not in the typical way you would deal a game like poker, where you give players equal number of cards. You see these inner rails are gonna have pretty much double the amount of cards that the two outer rails have. But that's sort of the idea, is that you generate however many rails from the input, and then you can see here, this is the answer from the example we're looking at. You're going to return it. You essentially concatenate the 3 rails together. See the part I have highlighted? It's the start, W-E-C-R-L-T-E. And then notice this second E starts the inner rail, rail 2. And then notice it ends with this bit. That would be rail 3. So you got rail 1, rail 2, rail 3 all joined together. And then, yep, we saw that in the test below. And then you'll have to do the reverse. So if you get this as input and it's fed through your decode string with number of rails, you get back to the original input. So the decode's a little bit more involved than the encode, so I'll start with that one. And I think that's about all you need to know. Assume the number of rails is greater than or equal to 2, and that passing an empty string will return an empty string. It's good to note the edge cases and keep those in mind. With that said, I think I'll get into it. The above example excludes the punctuation and spaces. Yep, but there are tests that include punctuation. Don't filter that out. So yeah, just whatever character's there, just take it. You could see a punctuation example down here too. So that's all. You don't have to check to make sure things are letters or not. That's, in my opinion, that's even makes it easier. So yeah, let's get into some encoding, since I think that's the easiest part. And as usual, pause the video and try this out yourself. And remember, with all of these, you don't have to just pause once at the beginning. If you hear me say something that triggers something in your mind, pause the video and see if you can take it from there at any point. Okay, good. So for my strategy then, I'm essentially going to create a string array that's going to hold the text of each rail. And then the analogy I use, kind of like dealing out cards, I'm going to iterate over the input string and sort of deal out characters one at a time into each of these, let's say 3 rails, or whatever size my string array is. And then finally, when I have all those rails sort of filled with text, it's as simple as joining each of the rails together in order. So that was the quick human speak. In code, we can do something like this. We can say string, I'll call it rails, oops. We want a string array, right? As I explain this, I'll use the example they provided for context. So I'll say, we'll think of it like an array of size 3, but we want new string num rail size for the general case. So good, we've sort of allocated an array here, doesn't have anything in it, but it's ready to take strings. Good. and then next. So you can probably imagine from my description, all the magic sort of happens in this weird sort of way I deal things out. It's not, you know, a nice orderly 1 2 3 1 2 3 1 2 3. It's 1 2 3 2 1 2 3 2 1 2 3 2 1. So and you can imagine we're going to need that sort of behavior in the decode as well. So what I decided to do was make a separate class that sort of encapsulates that complexity. It will just, imagine we just had something magical that could handle the dealing part for us. We could do something like, I call this class rail traverser, new rail traverser, and I'll initialize it with the number of rails. Obviously it would need to know how many rails to do its job properly. But let's say I have this thing that just works like that, right? Then it's a matter of going for each char ch and s, each character in the string, in other words. We can say rails, and imagine RT has one public method that could say something like get next rail. You know, it would start at 0, then 1 2 1 0 1 2 1 0, that sort of thing if you have 3 rails. And I can say, so you handle that complexity of getting which rail I should be loading next or I should be dealing to next. Whatever I just trust that you'll always give me the right answer. And I'm not saying you should trust that, right? You would code in your protections as needed, but I just mean from this standpoint, I'm sort of a client of this rail traverser class, and I'm saying, hey, that's your responsibility to get this right. And I'm going to load up whichever rail. I'm going to load the character into whichever rail you tell me next. And that's kind of cool too, because if you came up with a different order of dealing, you know, you could just change your rail traverser class or make an extension of it, and you could deal a different way, you know, and you could change that. But we don't need to worry about that. That's just the concept here. And then finally, once you've dealt this out, the rails array is filled with, in our case, 3 strings, this weaker old t and rail 2, etc. So finally you can say something like return our old friend string join. There should be no spaces, just jam them all together, and we would say rails. So in order to make this work, right, and this is nice, short, compact, easy to understand, just the way I like it. But in order to use that, of course, we have to implement the rail traverser class. I think that's what I called it, rail traverser. So what I'll say, I'll just make it a private class, rail traverser. And so let's do a constructor for it. You know, for the constructor, it's public and just the name of the class. There's no return type. And so obviously it would need to know the number of rails. That's just can't work without knowing that, right? It wouldn't make sense. And then let's give it some properties as well. So what would we want? What do you think we would need for this Rails traverser class to do its job? Well, I'm going to make a few private variables for this. I'm going to call it rail index. That'll just represent our current index. Could be 0, 1, 2, etc. Then I'll have something to store the number of rails. We want to save that information. That's going to be sort of a check, right? So as we're adjusting the rail index, we'll know, hey, don't go beyond the bounds of your rails. And then finally, I'm going to have this concept of a Boolean I'm going to call ascending. And so this is what I'm going to use to sort of achieve the snaking behavior, where I'm going to start out ascending. I know this drawing is inverted, but I'm calling ascending kind of going up by rail number, where this is rail 1, this is rail 2, rail 3. And the idea is when I get to the bounds of the rail, I'm going to stop incrementing rail index, and instead I'm going to start decrementing it to go back toward rail 1, right? So that's sort of how I'll achieve that. And then you remember we used public int, what do we call it? Get next rail, I think. And so we're going to have to implement that so it behaves in the way that we want. And so as far as initializing this thing in the constructor, I'll just kind of do it in line here. I'll say, obviously num rails is going to be equal to what gets passed in. Then I want my rail index. I'm actually going to initialize this to -1 because I'm going to increment to start, and so it'll get to 0. Don't worry, we'll make that work. And then by default, I want to start in ascending order always. So I'm going to initialize this to true. So that's good. We got that in place. So now, how can we make sure this works in the way we want it to? Well, essentially we have two cases, right? In the first case, we're going to be ascending. And otherwise, since this is a Boolean, there's only one option. It is descending. And the idea will be we'll handle business, and then we will return our rail index adjusted as needed. Good. So for the ascending case, you can imagine it's as simple as incrementing rail index. And we initialize that to -1, so the first time through this will jump up to 0, where we want it for the first time. And then you can imagine as we step through this, it's going to eventually get to rail 2, which is the max, and we have to handle that. So we'll say if rail index is greater than or equal to num rails, right? That's, hey, you went beyond, right? Because we increment every time. This would be like it got up to the value 3. Means we did 2 already. Now it's up to 3, and we got to sort of turn it back around. And so we'll say, don't ascend anymore. We need you to start decrementing. False. And then we got to correct the rail index. And so for that, I'll say rail index minus equals 2. So if it were at 3, it would go down to 1. If we're at 5, it would go down to 3, right? Hopefully you can see that sort of jumps back down a rail. We don't want to do 2 times at the end, at the bottom rail. So that's why I did a -2 here instead of a -1. And that should handle that, but then we got to handle the descending case. And if you can probably imagine it's very, very similar, except in this context we are decrementing. We're going back towards 0. And then we have to check if rail index is less than 0, right? That's when we have a problem. And we'll say, hey, turn around, start ascending again, and then make your rail index, we can jump it to 1. Means we already processed 0, we don't want to do 0 again, so let's go to 1. And then I got my return rail index. Good, I think this will do it. Let's go to the top here. Certainly tell us. This is a null. I'm just going to put in a dummy value here so we can start testing and seeing things. To do. How about that? So yeah, this is kind of like my dealer. That's the way I like to think of it. For each character, deal it into the right rail, and then join the rails, right? Not too bad at all, but I gotta see if I made any mistakes. Let's see, do I need to include anything? Don't think so. We will find out harshly. Okay, so look at this. This is cool. The test passed, and remember, I encourage you, as needed, print out your variable state as needed so you can see this thing executing. So we could say string s num rails. While you're developing, do this. When you're working in an IDE, you can just step through and you don't have to bother, but this is kind of the best we have while we're coding from our browser. Of course, the browser is convenient. We don't have to install any IDE or anything like that, but it does have its limitations. So put whatever you need in here. So maybe something else that might be helpful for you is what if we had something like rail index, And hopefully this will show us how this is sort of snaking around, give you a little more trust and confidence in that. So yep, you can see what problem you're dealing with here, number of rails, and it's doing, look at this, it's beautiful, right? 0, 1, 2, 1, 0, 1, 2, 1, 0, 1, 2. And if you wanted to test this some more, you could put in num rails equals 5 and just, you know, just playing around. If you wanted to write logic to do that, just to, you know, prove to yourself, hey, this thing is working kind of how I think it should. That's kind of like what unit testing does too. So I'm happy with that, and we're going to be able to leverage this for the decode portion as well. And boy, that made life simple for encode, right? So let's get into the more involved case, but not too bad here. It's just a little bit more work to do. All right, I'm going to actually remove the comment for the indices just so it isn't sort of polluting the output window, and I'm going to transfer this to the decode function. Let's move it down here so we can see what problem we're working on. Good. Okay, so decode. How are we going to do this? Well, we're going to break this one down into steps as well. So my strategy is going to be that my goal is to take that big long input string, possibly long, it doesn't have to be, right? But let's think of we are discovered flee at once. And so I want to break that up into separate rails. So you can imagine me using substrings to sort of extract each of the rails from there. And then the idea will be is that once I have these rails, I can sort of grab characters from them in a strategic order to build back to the original. So let's put some code in to make this a little more concrete. So first things first, I've got this idea of rail lengths, and we talked about how they're not equal, right? So we're going to have to handle that. But the idea would be something like list of integer, I'll call it rail lengths, and we just want to know how long each rail is so we can go into the original input and sort of extract the correct amount of characters. It can't be the same number, right? That won't, they're going to be different because the outer rails they get less characters, the inner rails get doubled up. So we could make some function that says get rail lengths, and it would obviously need to know s and the num rails. And we'll implement all this. I just want to show you kind of the high level strategy here, just like we did with encode. Just imagine there's something that we can consult that gives us the length of each rail, and then hopefully it's clear from that that you can start breaking this text, which will be the encoded one. Let's go to the decode section, right? We're going to get it this way this time, and so we need to know, hey, we want this one for rail 1, this one for rail 2, or whatever it ended at. You remember in the instructions, right? It's this blob and then avden for the last one, and that will really help us in sort of decoding this. So good, we got something that gives us the rail lengths. Now we can sort of start populating the rails. So it would be something like string array rails, and then again we'll just make a helper that could do something like load rails, load them with strings that have their text in them. And it would be, you need the input, you'd have to know the lengths of each rail to do this, right? So you know how many characters to grab each time, and obviously how many rails you have to work with. So just imagine again, there's just something that can get this for us. And now you have an array filled with these 3 values over here. Good. Once you're there, then we could do something like, decided to make a queue to turn, instead of strings, make these into queues where I can sort of dequeue letters off one at a time as I need them. So I could do something like queue type char, and it'd actually be an array of these, right? Because there's a string array, so I'm going to have a queue for each string. That's why I'm doing an array. You could call it queues, and you could make something like get queues for Rails, something like that. And you would pass in the string values, and then it would sort of chop up the string into characters and load them into queues that are, you know, just as a convenience to work with. You could do it with string form too if you sort of indexed into the string, but thought why not? Queue, more data structures, more learning, right? And it's kind of convenient. I do like it. And then the idea being then is that I sort of make another one of these dealers that can work with the queues to get the characters it needs. So I would say new rail traverser, and we have to give it the num rails. We know that it's initialized that. That's how we implemented that. And then the idea being is that we're going to sort of make this into a single string as the result. That's what the contract says, right? Return a string. So since this, I'm kind of appending characters on from multiple rails all at once, my idea is that, okay, the string's getting modified a lot. Let's use a string builder instead of a regular string. That's why I did that. You could do it with a string as well if you wanted, if you're more comfortable with that. But string builder isn't complicated to use. And I'll call this result actually, because I usually call what I return that. And then once we have all that in place, right, it's sort of like we'll build this result. And so what's our condition? We're going to do a while loop, and the idea is as long as we have any characters remaining in any of those queues, right, that means there's still letters to add to the result. You haven't processed all the letters until all queues are empty. So how can we express that in code? While queues, and we'll use an enumerable link method here. We'll say, I'll do it this way, any, and I want to know that any of their counts are greater than 0. Remember, queue has a property. Let me go over to queues. If you don't remember this, go to your queue doc page, and one of its properties is the count. So it'll tell you how many items are in the queue. If it's greater than 0, it means there's still stuff in there. I hope that's clear. So any, I'll use queue as the parameter name for my lambda here, since it's queues is filled with queues. And then we can say while any queue count is greater than 0, right? So as long as that condition exists, keep looping is what I'm saying here. You could probably do, you could invert the logic. I'm sure there's another way to write this. You could go queues all and check if they're empty. You know, if they're not all empty, you'd have to negate it. So whatever's clear to you. Okay, so what do I do now in this while loop? And the idea is that for result, we're going to build a string. It's empty to start, and we're going to append to it. We're going to deal characters into it one at a time. This would be like plus equals in if you're using a regular string. It's called append with a string builder. So what do we want to append? Well, we have our queues collection, right? And we're going to use our dealer to sort of go through and get us the value we need. Get next rail, right? And so that'll give us, that'll point us at the proper queue, and then to actually get the character, we have to say dequeue. Consult the doc page if you need to, but that's how you extract an element from a queue. It's like popping from a stack. They call it dequeue with a queue. That's a FIFO structure. FIFO is first in, first out, so you get whatever was put in there first. And so let's see, I got my parentheses matched up. But yeah, basically this, right? So you get to use the same rail traverser it's going to go 0, 1, 2, 1, 0, 1, 2, 1, 0, and it's going to go through these queues, which are basically the same. Remember, the queues are basically the same as the rails. They were in string form, and now instead they're just a collection of characters. Same kind of thing though, you know what I mean? But I'm just using this DQ. I put it in queue form because I like working with it that way. And so that'll keep going until this condition is not true, where all the queue counts are 0, meaning they're all empty. And then finally, you have built up this string, and you can say return result. Make sure you say toString if you're using a string builder. If you're using a regular string, you don't need that. But yeah, not too complicated, right? But of course, we haven't implemented any of this stuff yet. We've got to do that to make the magic happen. But hopefully you kind of followed that just to see my strategy there. So again, you can pause and implement these methods on your own. Try them one at a time if you want. Otherwise, we'll just start going through them. So let's make a private static, what did we call this? Get rail lengths, right? And it's going to take a string text, and it's going to take an integer number of rails. Okay, and so how can we get the rail lengths given the text? And so I typed out a bit, so you don't have to watch me type it all out, but I kind of made this little illustration for how the characters get distributed. Maybe I'll paste that in here. So I just used an example of 5 rails. You can do this with whatever you want, but I wanted to show you how the letters go, right? These would be the numbers after each rail are the index into the original input string. So we are discovered at once, or this jumbled encoded form of it. And so you take index 0 there, index 1 goes there, 2, 3, 4, and then notice how it goes 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, etc. Take this out as far as you want. But what I wanted to show was that essentially the inner rails are double the size. There's 6 there and there's 3 here. And now note that your text may not be a perfectly even length, right? You kind of start from the top again, and notice how this top rail has 4 elements and the other one only has 3. So you kind of, if you have leftovers, then you have to start adding them on to the end. So this rail 1 and rail 2 got a couple extra characters. But we're going to be able to generalize this form, and I thought this little illustration might help you visualize that instead of just typing out the math of it. So with that in mind, what can we do? Well, my idea is, I'm going to say int num parts. And what I'm going to do is I'm going to say num rails minus 2. These are, when I say num rails minus 2, this means how many outer, or I'm sorry, how many inner rails I have, right? Because there's 2 outer rails, a top and a bottom. And so if you subtract 2, what's left is the number of inner rails, which are going to have twice as many elements in them. So I give them a weight of 2 parts each. And then the idea is that I'm going to add 2 for the outer rails. And I just think of this as parts. It's just a general term. The part size is going to be based on how long the text is, but this is going to give me just parts, so I can determine that. Okay, and so the part size, I've got a number of parts, but each part size then would be the text length divided by num parts, right? And then, like I said, there's a possibility that this doesn't divide evenly, so we're going to note a remainder, and that would be, we can use our friend modulo for that, so that would be the text length modulo the num parts. So we'll use this remainder. We're going to use these first 2 to get kind of the general size. We'll initialize that, and then we'll use the remainder to give extras where we need to, starting from rail 1. That's sort of the idea here. And then, yeah, let's start making these rail lengths. You know what? I didn't even put the return type in the method, so let's do it as a list. That's what I wanted to do here. It's just going to list each rail size in order from rail 1, rail 2, rail 3. So we're gonna set this thing up to start, and we'll tweak it with extras as needed. Deal out some of those extra sizes. So list int of rail lengths. We'll just very crudely, we can say enumerable repeat, right? We're just going to repeat a value. And so we'll start out with giving everyone a part size and the number of parts. And then we'll put it into a list form first, right? Because we know repeat just returns sort of an IEnumerable collection, so we got to make this jive up. Okay, good. Now we can sort of modify this to give the extras where they're needed. I'll say rail lengths, and I'm going to transform that. Hopefully you remember the enumerable method for doing that. Select, right? And so each element represents a length, and I'm also going to work with its index. So you remember that the select has 2 overloads. You can use just the element itself, or it has an optional overload to bring its index position. So like if you were using a for loop, index 0, index 1, index 2, you can include that. And I find the index useful here, so I'm going to include it. And then the idea is that if it's an inner rail, I essentially want to double it, and if it's an outer rail, just leave the length as it is. So how can I say that? I could say if index not equals to 0, because that's the first rail, right? And index not equal to num rails minus 1, that would be the top or bottom, whatever your perspective is, not one of the outer rails. If that's the case, right, then I want to say, hey, double the length times 2. Else, just pass the length. The outer rails were already set up to their base size, so that's good. But if it's an inner rail, just double it. And then, of course, select returns an IEnumerable, so I gotta put this back to a list to reassign it to rail lengths. So I'm kind of modifying it there. All I did was I just doubled the inner rails. That's what you can think of that line as doing. And so now we've got to handle this case where there were, it didn't divide evenly and the remainder value is non-zero. So let's get that handy rail traverser to deal them out. See how convenient this thing has become? New rail traverser, and we got to initialize it, right? So let's work right with the remainder. While remainder is greater than 0, let's deal these things out. So we could say, let's make a scope here. We could say plus plus rail lengths at, remember, RT get next rail. That'll start at 0 for us. And that's just saying bump the size at, to start, bump the first rail, deal out these. Let me go back to my diagram. It's going to say, so up to this point we only had here, and so we have indices 24 and 25 left over. It's going to say, hey, bump the size here from 3 to 4, and this one, because the remainder would have been 2, and it's going to say go to the next rail, rail 1, or I'm sorry, I was using 0-based numbering, rail 2, and give that an extra count. So instead of 6 here, this will be 7. But rail 3 will still be 6, rail 4 will be 6, rail 5 will be 3. They won't be modified, right? So this will just handle. If remainder is 0, this part will never even execute. And then whenever using while loops, don't forget to update your state so you can break out and not get stuck in a perpetual loop. Okay, that should handle our remainder. And then finally after that, we are safe to return our rail lengths. And I think that will cover us. Again, if you want to see this stuff executing live, put in your print statements to do that. But good, we got get rail lengths implemented. What else do we have to do? Well, we have to make this load rails, don't we? And it should return a string array. So let's say private static string array load rails. It should take a text. It should take a list of rail lengths, right? Because we saw they varied, and then the number of rails. We need to know how many of these we're making. Good. Let's load the rails up with their individual strings. So for load rails, let's start by initializing the array. String array rails equals new string num rails. That's how many we're going to have. Oh, wow, there we go. And then now we've got to sort of load these up. So let's make a for loop for that. I equals 0. I is less than num rails, and plus plus I. We'll define our scope for this for loop, and then we can start building this up. So the idea is that we're going to have a starting index, and then we're going to use the strings substring feature method to sort of take the appropriate number of characters. Remember the input text that we have that we called text. We're going to start at 0, right? And we're going to take the number of characters that are defined in rail lengths for rail 0 or rail 1 if you're using 1-based numbering. So I can do something like this. I can say int start index, and that will be equal to rail lengths. And I'm going to use the handy enumerable take I dot sum. And then I can say rails I. We've got to load that up. And we can say text substring. And we will say the starting index and the rail length. Rail lengths, I. It's going to be the first rail, then the second rail, etc., until all of these get populated. And then finally, you can simply return the rails that you constructed. Return rails. So note when I is 0, right, take's not gonna it's not gonna skip ahead in the collection, but it will skip ahead as we increase the rail number, right? Because with this text, we don't always want to start at 0. We only want to start at 0 for the first part to get this we control LTE. You know what I mean? That rail lengths for index 0 would have a size of what, 7? Is that I have highlighted? 7. So we want to take that. But then the next time through the loop, we don't want the same start index. We want the start index to be at position, I think this would be index 7, right? And then you take this whole bit. And then the next time through the loop, you want your start index to be, oh, I didn't mean to shuffle that. You want it to be the avden part. So I hope that's clear. That's why I'm sort of moving this starting index as I'm doing it. And then remember, substring, you give it a count. So I'm using the rail length to determine how many letters to take. So that's for load rails. What else do we have to do? Now we've got a string array containing all of these gibberish rails. We needed get queue. So let's just transform an array of strings into a queue. We could say private static queue of type char array. I called that get queue for rails. It should take a string array call it rails. Okay, so let's convert these into queues. First thing, let's just initialize the array, size it properly. You can say queue char array, call it queues, and I can say new queue of char, and our size will be the rails.length, right? The array length is how many rails it has. Good. So now we've got to go through the rails and load up queues for each of them. So we could make a for int I equals 0, I is less than rails.length, increment I to find the scope of our for loop. And so in here, we got to be sure that for our queue array, we're actually initializing a new queue, right? Allocating memory for that queue in the array before we try enqueuing characters into it. So let's say queues I equals a new queue of type char. So this is, you know, we do this whenever we use a list or anything. We got to initialize it before we use it. Okay, good. And then we'll go for each char ch in rails I, and each rail for each character, remember they're strings, then we can say queues I and load up and queue the character. And so this will make a sort of rail queue. It just converts the rail into a queue form with each of its characters in it. And that's really all you have to do, and you can return your queues. Return queues. So I think that'll cover us for get queues for rails. What else was there? We already implemented the rail traverser, and then, yeah, I mean, see how easy this becomes now that we have everything in a what I think is a handy format as queues. You simply just sort of deal them out, you know. You got nothing, an empty string, and sort of snake through from your dealer there, get the right rail, and pull the right letter from it, add it to this result, and when you're done, return the string. So I'm going to let's hit the test for that. See, I must have typed something wrong with all that typing. Solution 46, identifier expected. Let's go to line 46. Maybe you've seen this already. Saw the problem a long time ago. What did I do here? Oh, sure, look at this. Didn't even say the type. Just listed, how about int? Come on, man. Okay, the typer namespace, that's fair. We're using queue, we're using list. Hopefully you know by now, if you're going to do that, system collections generic. And then we're also using link methods, aren't we? So while we're here, using system link. Okay, let's hit the test again. See what else I messed up. 25. Oh, sure, we use string builder. So you might not remember, but you can look it up. It's easy to find out what namespace things are in, but it should be system text. What do we got? What do you got for me now, compiler? There we go. Happy green. And so, yeah, here's just some saying what problem we're on the initial input. Again, go through this. Any of these methods, if you thought they weren't clear how I explained them, add some console write line statements in there so you can see, you know, the sizes being calculated, you know, in the decode example, or characters being queued up or dealt out. You know, this is your chance. If there's something unclear, that's the best way to sort of visualize that. And I think that always helped me when I was confused, is just visualizing it. So, but we have not achieved victory yet. Let's hit the attempt and see what we get. Okay, so we can claim victory. That's good. I'm going to expand this. I know with these more difficult challenges, the the size of the implementation gets bigger. So I'm going to go through here and clean mine up. I wanted you to note though that again, I keep my public methods at the top. People who just want to work with this class, you know, I'm not going to make them scroll through the screen. They can see what they got and what they get to use. I will remove this before the final submission. Maybe I'll leave my other comment because I think it could be helpful. That looks pretty good. Maybe I won't worry about the indenting errors, but I noticed that the initial indentation was messing with me. We got all of our private methods in class toward the bottom here. That looks, I'll get rid of this. That looks good. We'll leave that. Rail traverser looking good. And note, like all these helper methods, right? They're nice and short, right? You can understand them. Now, I didn't have to break these out into separate methods, but then you could imagine what a mess my decode method would have been had I tried to pack all of this logic, which here they're really reasonable and short, and you can understand them quick. But had I done that with my decode method, it would have been a hot mess, in my opinion. It would have been way too long. And look at this, I only have, what, a handful of lines now? So, I don't know, I think that's winning. I like that. Maybe I will address my OCD and fix the indentation on these public ones too while I'm here. But you know what to do. You can submit yours, get your kata points, and then see what you can learn from other people. As we get into more complicated problems, there's obviously going to be really varied solutions, and so there's a really good opportunity to see cool things that people do. There's so many smart people solving problems on here. It's nice looking through those when you're done. So yeah, I think I'll submit mine like this. I don't think that one comment's terrible. Of course, they're going to make us run it again because I made modifications. So let's make sure I didn't bungle anything there. And good, we're clear. I'm going to submit. And yeah, let me know what kind of strategy you took. Questions, comments, feedback is always welcome. I appreciate all that. And those of you who are liking the videos, that's really nice too. I really appreciate that. It's thinking, but hey, we finally got in, and wow, like look at this. That's beautiful. That's, you know, maybe not necessarily clear when you look at it, but you know, wow, that's a nice and compact way to solve the problem. So yeah, I'll do my part and go through these, see what I can get out of it. You do the same. Otherwise, thanks for watching. I'll see you in another video.